Welcome to scikit-learn Test Predictions Using Various Models by Julian Avila, a video course by Pact Publishing. I am Adam Stewart, and I will be Julian's voice for this course. Julian Avila is a programmer and data scientist in the fields of finance and computer vision. He graduated from the Massachusetts Institute of Technology, MIT, in mathematics, where he researched quantum mechanical computation, a field involving physics, math, and computer science. While at MIT, Julian first picked up classical and flamenco guitar, machine learning, and artificial intelligence through discussions with friends in the CSAIL lab. He started programming in middle school, including games and geometrically artistic animations. He competed successfully in math and programming, and worked for several groups at MIT. Julian has written complete software projects in elegant Python with just-in-time compilation. Some memorable projects of his include a large-scale facial recognition system for videos with neural networks on GPUs, recognizing parts of neurons within pictures, and stock market trading programs. Let me brief you about this course. Scikit-learn and Python allow fast prototyping, which is in a sense the opposite of Donald Knuth's premature optimization. It has allowed us to prototype what was impossible, including large-scale facial recognition systems and stock market trading simulations. You can gain instant insights and build prototypes with scikit-learn. Data science is, by definition, scientific and has many failed hypotheses. So let's have a look what we've got in store for this course in detail. Section 1. Linear Models with Scikit-learn tells the story of linear regression, the oldest predictive model from the machine learning and artificial intelligence lenses. You deal with correlated features with ridge regression, eliminate related features with LASSO and cross-validation, or eliminate outliers with robust median-based regression. Section 2. Linear Models. Logistic regression examines the important healthcare datasets for cancer and diabetes with logistic regression. This model highlights both similarities and differences between regression and classification, the two types of supervised learning. Section 3. Building models with distance metrics places points in your familiar Euclidean space of school geometry. As distance is synonymous with similarity, how close or similar or far away are the 2 points? Can we group them together? With Euclid's help, we can approach unsupervised learning with k-means clustering and place points in categories we do not know in advance. Section 4. Cross-validation and post-model workflow features how to select a model that works well with cross-validation, iterated training and testing of predictions. We also save computational work with the pickle module. Section 5. Support vector machines examines in detail the support vector machine, a powerful and easy to understand algorithm. So, what are we waiting for? Let's begin this journey together, and I hope you will enjoy the ride.